Okay, so we're going to move on now to, I think it's Marie next, or is it?
Ashley.
It's Ashley next.
Oh no. Is it Marie?
I think Marie next.
Okay.
Yeah, Marie's not. Marie, are you there? I think you're up next. Yeah, on my agenda, you've got next slot. Yeah, so I think Marie's going to talk to us about the sort of the bigger picture of how we may use Earth observation tools, etc., to understand where aquaculture occurs. And I think, that, again, this is probably going to fit very nicely into the environment part of that One Health wheel, and it shows the kind of people you might need to be in aquaculture. And I think I'll leave it to you to explain more.
Thank you very much for the introduction. Good morning, ladies and gentlemen. Thank you very much for giving me the opportunity to talk with you today. I'd like to thank my speakers who have definitely introduced the subject matter very nicely. So yes, I'm here to talk to you today about the National Oceans and Coastal Information Management System, which is a support tool mainly aimed at the marine aquaculture industry. Okay, so aquaculture was identified under Operation Pakisa, a national development plan that kicked off in 2014 as one of the key areas for expansion. As mentioned before, aquaculture is a relatively young industry with a lot of potential for growth and adding a lot to South Africa's gross domestic product. In terms of marine aquaculture in South Africa, many of the species that are focused on include mollusks or things like abalone, mussels, and oysters, and also to a smaller extent finfish. And depending on the cultured organism, this might be farmed in pens or in water cages and rafts, for example, finfish and mussels and oysters, whereas a lot of the abalone might be grown in land-based pump ashore operations, and each of these have different environmental risks associated with them. If you are in the marine environment, unfortunately, in South Africa, you are exposed to harmful algal blooms. So these are from microscopic plant-like organisms called phytoplankton, and although they are a vital part of a healthy ecosystem, some of them can be harmful to the aquaculture industry. This can either occur through toxicity, where when they're absorbed by some of the organisms like mussels, and then when consumed by people, it can be harmful to the person. Some of them can also cause mechanical damage to the species. For instance, can cause clogging of the gills. And these events can also, if they're big enough, they can cause hypoxia if a bloom collapses. Unfortunately, these harmful algal blooms have a lot of economic risk to the aquaculture industry in South Africa. For instance, a harmful algal bloom that hit Hermanus in 2017 caused approximately 70 million rands worth of damage and losses to the abalone industry. So as you can imagine, there is a lot of interest from abalone farmers or from aquaculture farmers in general for monitoring these types of events. And that is one of the things that the National OCIMS under Operation Pakisa Initiative 6 is aiming to do through providing technological solutions that incorporates all the scientific knowledge, the information, the data, particularly from satellites, and using these to the benefit of the relevant stakeholders, such as the abalone and aquaculture farmers, for use in operational and strategic planning, and risk mitigation. Through OCIMS, we have developed several decision support tools, and these are several across the marine domain, for instance, marine spatial planning, coastal flood hazard, water quality, and one of them is specifically aimed at fisheries and aquaculture support. These decision support tools are developed through consultation between the scientists, the developers, and relevant stakeholders. So in terms of the decision support tool development cycle, we work together with champion users. So these might be people in the industry that have a vested interest in trying to make this tool work. And they help us to identify the specific needs and decisions that they need to make on a daily basis. We then research and develop the most appropriate products that could be helpful to them and provide these as value-added products to them so that they can assess the usefulness And forms a circular iterative system with the stakeholder engagement at the center. In terms of the needs of the industry, operational risk management and resource management, specifically in terms of harmful algal bloom detection, came out as the top priorities. And these information are used by not only the aquaculture farm managers, but also government, municipal managers, disaster managers, fisheries managers, and regulators. The type of information are also needed both in near real time and also at an historical time space. And this is generally used to figure out the bloom's proximity, the spatial extent in terms of its persistence, in terms of whether it might cause an anoxic event, and also the inherent risk due to the phytoplankton type. Now, although in situ data collection, such as counting the types of phytoplankton in the water at a farm level, are very important, and you can't go without that, point-based measurements just do not cover the spatial and temporal scales that is possible by satellites. So that is where I come in. I'm an Earth observation scientist in the CSIR, and our research is focused on understanding the regional oceanography, how it affects HAB formation, and specifically assessing the best satellite sensors and detection techniques to be able to detect these harmful algal blooms, and creating regional algorithms to improve the satellite-derived products where needed. So for instance, in terms of detecting phytoplankton biomass, the standard satellite products provided by environmental satellites generally tend to not be able to resolve the really high biomass that you find in South African coastal waters. So we've actually had to design regionally appropriate ocean color algorithms to cope with these conditions. Biomass information also doesn't always give you the inherent risk associated with these blooms. So we've also designed algorithms to try and tease apart the phytoplankton types so that we can identify the potentially harmful blooms from the background phytoplankton signal. And all of this research has culminated in the development of the OCIMS Aquaculture Decision Support Tool. This is a web-based viewer where most of our products are displayed. It is if you can see on the left-hand side, you have the big product window that is showing a map view of the different products, in this case, a chlorophyll image. It also has bloom analytics that's overlaid, so showing the specific areas of potential concern. There's buttons to jump to the highest risk areas, a date selector and scrolling function, so you can either pick a particular date in the past or scroll through the dates at your leisure. There's also a product selector. This website was actually updated yesterday, so there are now even more products available. And there's also a 7-day bloom persistence indicator to give an idea of the potential risk for anoxia. Unfortunately, I didn't put a link to this or a QR code, but this is freely available. You could reach it if you go to ocims.org or ocims.co.za, sorry. And you should be able to reach this desk and the services. It is a free service. So apart from the web-based dissemination tool, we also provide image-based or regional image-based service. So basically, make these images available so that they can be used in government advisories. We provide them on regional WhatsApp groups that are particularly active during bloom events. And we also send out email HAB bulletins during the high-risk periods, during summer months when there's lots of blooms happening. And here I just provide an example of the decision-making and information uptake that might occur. This specific example is an abalone farm in Walker Bay. So as you can see, during the routine months, particularly in the winter when there's not a lot of bloom activity, they might only use the web tool and they might only look at it once a week or so. However, as summer approaches and the bloom risk period becomes higher, They start looking out for the email bulletins, and if an actual event is happening or if there's more phytoplankton counts in the water, they might start relying on the regional WhatsApp groups where we provide the images as quickly as possible, and they share information about the phytoplankton counts at their specific farms. Cool, almost done. In terms of success stories, I mentioned the abalone farms and the Walker Bay bloom in 2017. Unfortunately, this caused massive losses, and at that point, the OCIMS decision support tool was not available yet. However, by 2019, we had released this tool and we had informed the industry about it, and they were very happy and excited about it. And that year, the information was shared, they had access to the tool, and there was a bigger red tide that persisted for longer, and that year there were no losses to the abalone farms. There's also user testimonials on the right-hand side of the image there where people from around the country had expressed their happiness at the tool and its use. In terms of OCIMS, we are now in the second phase of the OCIMS project, a 5-year project. We're in the first year, and we're hoping to include several exciting new products. We'd like to include a geographic information system to help the farms to share their farm-based phytoplankton counts with each other. And we also want to make all of our historical Earth observation data sets available online on data cubes so that we can incorporate and include the research community so that we can all help work towards a HAB prediction tool in the near future. Thank you very much. That is it from me.